Alright, so first we're going to fill in this how money and energy are similar chart. We talked about this in class, but if you weren't here, we talked about how money can come in many forms, like your cash or your checking account or gold or savings account, paycheck, dollar bills, coins, all that stuff. And similarly, energy can come in many forms. We already took notes on the 8 kinds, so I'm not going to stop here all that long. And then we talked about how money you can change forms. So if you go to the ATM, you can take money from your checking account, now it's cash, or you can take your paycheck and deposit it into your savings account. And it's still that same amount of money, just changed forms. So energy is the same way. So a falling object would turn gravitational potential energy into kinetic energy. When you plug in a fan, you're turning electrical energy into kinetic energy because it's going from electricity to motion. And then we looked at some examples. Lewis in the balloon, he blows up a balloon. It's got a propeller on it. So you take elastic potential energy from the balloon and it turned into motion in this really awful squealing sound. And then we did the fire syringe, which you should look up on YouTube because it's pretty cool. It takes chemical potential energy and motion energy and turns it into thermal energy and light energy. So you see something light on fire, so that's pretty fun. And then we talked about a roller coaster as well. So you start up really, really high with gravitational potential energy. That gets turned into motion, sound, and thermal energy. So changes happen when energy is transformed from one type to another. That's when you see a change. All right. Then the next day, we talked about United States energy use. So we looked at where energy starts, so whether in your fuel supply, there was more down here. Let's see if we can fix that real quick. It's going really slow. That's okay. Down here into the sort of renewable types of energy or green energy, like hydro energy is down here. Let's get back to this because this was not effective. And so we talked about energy in the U.S. We start with 85% of our energy comes from chemical energy. Only 0.1% comes from like light. And we use the energy mostly in transportation industry and then commerce and residential. 41% of the energy we end up with is useful in terms of motion and heat. 14% is useful electrical energy, but 45% is wasted as either heat or sound. So when we go back to our analogy, when we say wasted energy, that's like an ATM fee, like a fee you were charged just to get out the cash you wanted. Or your laptop, it gets really, really hot. You don't need your laptop to get hot. You need it to produce some light and sound, but it gets hot as well. So it's kind of like the cost of doing business. And then lastly, energy is always conserved. So if you had $1,000 in your checking account, you wanted to take out $997, that $3 ATM fee will get you. That would still add up to $1,000. Or you could take your $1,000 and go to an ATM without a charge and take out $200 and maybe purchase $800 worth of gold, and that would all still add up. So your laptop takes 1,000 joules of electrical energy. 200 of that becomes that wasted thermal energy, but then you get 800 joules for the light and sound that you wanted. All right, so then we talked about which of the kinds of energy from all the examples were useful and wasted. So the green is useful. The red was wasted. So elastic potential, the motion was useful. The sound was a waste. Same with the fire syringe. The heat energy was the useful energy. The light was wasted energy. And then the roller coaster, the motion is what you want to get out. The sound and the heat on the tracks are just extra. And we didn't talk about that one. All right, then we did an investigation of kinetic energy. If you haven't done that, you probably want to come in and do that because that's where your CER homework came from. And then we talked about the equation for kinetic energy, which is 1/2 mv squared. Okay, you need to know this. 1/2 mv squared. You need to know how to calculate it. The m stands for mass, the v stands for velocity, and we can abbreviate kinetic energy as KE. This is what each of those is measured in. Joules is the most important and the newest one. That's how we measure all kinds of energy. So then we went through an example problem. Calculate the amount of kinetic energy of the metal ball with a mass of 0.1 kilograms, and it's moving with a velocity of 0.9 meters per second. So the goal, you need to calculate kinetic energy. What you already know is mass equals 0.1 kilograms, velocity equals 0.9 meters per second. The equation you're going to use is KE equals 1/2 mv squared. You're going to take that number for mass and plug in, and that number for velocity and plug in. So if you're having trouble with this, come in and see me. And then we did a practice problem on our own. All right. Then we did the energy skate park activity, which you can follow along because you can actually get to this from any computer. You just need to Google energy skate park and click on the first link. And then we did a gravitational potential energy investigation or lab. So gravitational potential energy is calculated by m times 9.8 times h. And you're going to use that in this following practice right here. So in this one, you're asked to calculate the amount of gravitational potential energy of a metal ball with a mass of 0.1 kilograms when it's held at a height of 0.3 meters. So the goal, I need to calculate potential energy. The given values, m equals 0.1 kilograms, h equals 0.3 meters, and your equation is that GPE equals m times 9.8 times h. And then again, all you need to do is plug in. And then we did one more practice problem, and that should get everyone all caught up.